Hi, welcome to StatStuff. I'm Matt Hansen. In this lesson, we'll review the Tack Time metric that's used for measuring flow within a process. There are no prerequisites for this lesson, so let's begin by defining what Tack Time is.
Well, Tack Time is defined as the measurement of the consistent flow required for a process to be equally balanced with the customer demand. Takt is basically a German word for a drumbeat, and it implies a consistent flow or beat or regular pace within the process. The calculation for Tack Time is the total available work time per day or shift divided by the total customer demand per day or per shift. The key thing here is to keep them at the same level, that is at per day or shift. Whatever method is used on the numerator should also be equal to the method used on the denominator. So when calculating Tack Time, try to use the lowest reasonable level of units for measuring time. This usually means using a numerator value that exceeds the denominator value. So it's okay if you get into small measurements like hours, minutes, or seconds. So the key is to keep that numerator larger than the denominator. So let's go through a couple examples. Basically, let's say that you have a production line that operates 10 hours a day and the customer wants 300 units per day. Then the Tack Time would be 2 minutes. That is, you take 10 hours. Well, 10 is less than the smaller numerator than the 300 units. So we want to make that 10 hours converted to, let's say, 600 minutes. Then the 600 minutes divided by the 300 units equals 2 minutes. So by saying 2 minutes is our Tack Time, we're really saying that each unit is going to be running through the production line about every 2 minutes. Now another example might be a little more complex here, where a company has 2 production lines that run 24 hours a day in order to meet the customer demand of about 5,000 units a day. Now the Tack Time here would be 34.6 seconds. The way this was calculated was saying that there is 24 hours of actual production time per each of the production lines themselves. Since there's 2 of them, we multiply the 24 hours times the 2 production lines to get the total 48 hours a day of production time. Or that's equal to 2,880 minutes per day, which is also equal to 172,800 seconds per day. The reason why that was calculated to the level of seconds is, again, to get a numerator that's larger than the denominator, which would represent the 5,000. Since minutes is smaller than that, then we drilled down to the seconds level in order to get a much larger numerator. So we divide that by the 5,000 units a day, and that gives us that Tack Time of 34.6 seconds. Again, just like an example above, that would mean we would expect that every 34.6 seconds we would see a unit flowing through each of the production lines. Now, what if the customer's demand changes? How does that reflected in the Tack Time itself? Well, if the demand from the customer decreases, then that means the Tack Time overall will increase. That is, we'll have a slower process in meeting that demand. So it may not always be ideal to slow our production to meet the demand, but what we might want to do is try to find ways to reduce the numerator. That is, reduce the number of staffing or the amount of shift hours that are available in order to balance that more with the customer's demand. But what if the demand actually increases? By increasing, then the Tack Time will actually decrease. That is, we'll have a faster process where things will be moving through the process at a much faster pace in order to meet that demand. Well, if the production is maximized to capacity already, if we can't increase the amount of production, we can't make it go any faster, then we might look for other areas of potential waste, like in setup time, for example, that could help to reduce the production cycle time or the overall turnaround time within the entire process. So the production load should always be balanced by comparing the Tack Time to the total turnaround time.
Alright, before we close this lesson, let's discuss how we can apply some of these concepts in a practical way.
What I'd like you to do is identify at least one process that you interact with on a regular basis, especially a process that might be measured in cycle time. Now what I'd like you to do is calculate the Tack Time for that process using the cycle time and volume, or customer demand. Now calculate that same Tack Time, but instead using historical volume or customer demand. For example, using the same method or calculating it back for 3 months ago, 6 months ago, or 1 year ago, depending on the amount of data that you have available going back historically. So now I want you to ask yourself, how has the Tack Time changed between now and over those historical time periods? And how has the process changed, if at all, in order to accommodate for those changes in the Tack Time? And then finally, if the tack time has increased, that is, if it's a slower process, then how has it affected the production costs impacted by that slower process?
Well, that wraps up this lesson. Check out StatStuff.com for many more resources that can help you achieve powerful results. I'm Matt Hansen. Thanks for watching.